So this time we're doing routine oranges. You're given n by n grade where each cell can have one of these three values. 0 represents an empty cell, 1 represents a fresh orange, 2 represents a routine orange. Every minute, any fresh orange that is 4 directionally adjacent to a routine orange become routine. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If it is impossible, return -1. So since this problem asks me to get the minimum number of minutes, we traverse layer by layer. So I can model this problem into a multi-source BFS, and the source would be the initial routine orange, and start from the source we do BFS around this orange until the end, and we see, and then we check the processed orange versus the total number of orange. If they are the same, that means okay, we return a minute. If they're not the same, that means okay, there are oranges that is not reached. So impossible, we return -1. Yeah, so the idea is pretty simple. I start coding. So I'm going to traverse this entire grid. Purpose is that I wanted to add all the initially rolled orange into the queue, and also check the number fresh orange that we'll use later. Okay, if this is 2, okay, we add this node into the queue. This is minute 0, minute 1, minute 2, minute 3. Okay, so we create a visited site. Append it. Okay, so that's the initial setup, and well, the directions they can move, as I said. 4 direction adjacent. So it will be like this. And we also have, let's call it root, the newly routing, sorry, 0. So we are going to just alas, we want the newly routing should be the same as the fresh, or okay, let's think about how to check which one is newly routing. Because we need to mark it as routing anyways. Okay. Okay, if the equals fresh, just return the so-called distance. We just return the distance. Let's have the distance as infinite right now. Else it's just an impossible return. -1. Okay, now we start to do the traverse. Dot this, and we check if this is this was fresh. Okay, this was fresh, so at this point it's routing. So just newly written postpone. If it is written, then we don't update this. Okay, now we add the child. Okay, in this case we just updated the new one. And we're going to check if the new one is valid. And it's fresh as well. And it's unvisited. Okay, do not listen to music. If it's within range, it's not visited and it's fresh, that's a valid traverse. We're going to append it to the queue. Okay, and also edit it into visited. Okay, now for this we traverse, and at the end we will figure out, okay, what is the distance. So right now we wanted to get what is the distance right now? So every time we pop, we always try to update the distance. So we want to have the max of minute and distance. Yeah, that's it. This should be visited. Okay, awesome, this works. And for time complexity, it'll be n by n, because we need to traverse every node, process every node for one time, put into the queue, pop out of the queue. And for space complexities, n by n, because we create a data structure for queue and the set. That almost just have all the node there. So that's all.